Welcome to a new video. Today we are going to talk about categorical data handling techniques. First things first, let's import the libraries we will need for this tutorial. We will import pandas and numpy, and then we are going to import label encoder and one-hot encoder from sklearn. One-hot encoder. Alright, we have imported pandas, numpy and the necessary modules from scikit-learn. These will be crucial in helping us manipulate data and apply the encoding techniques. Before diving into the code, let's create a simple dataset to work with on this tutorial. I'm going to create a data with some categorical features. So I'm just going to make a copy paste here and let's see what data looks like. The only categorical feature we have is country here. We are going to work with that on that tutorial. Okay, here we have a small dataset that has a country column with categorical data. We also have age and salary as numerical features. The country column is what we will focus on for encoding. The first technique we will look at is label encoding. This method assigns each unique category in your data a numerical label starting from 0. So what we will do is we are going to initialize the label encoder firstly. We will take the label encoder class and then we are going to say df and we are going to open a new column here. We will say country encoded and also let's say label here, and then we can say label encoder. We are going to use fit and transform methods from label encoder and we will say df country. Here it is, and also see the data frames new version here. You can see that we have added a new column called country encoded where each country is now represented by a unique integer. Label encoding is straightforward, but be careful, the numbers can imply an unintended ordinal relationship between the categories. For example, Germany being labeled as 3 and Brazil as 4 doesn't mean Brazil is greater than Germany in any way. Now let's move on to one-hot encoding. This technique converts each unique category value into a new categorical column and assigns a binary value which are 1 or 0. So just like the last one, we will say one-hot encoder and we are going to initialize this. We are going to use the class, this one here, and then we are going to apply this. So I'm going to apply this in another data frame and I'm going to make a merge operation because I don't want our data to get too messy. It's going to create a column for each unique entry. So let's just do this in next step because I want it to be more simple. Let's say one-hot array is going to be equal to the one-hot encoder dot fit transform, and we will say df country, and we will use toArray here. So let's see what it returns. One-hot array. So you can see here that it encoded with 1 for each unique value. Like the first column here is for the Brazil and the second one is for Germany, etc. So let's concatenate this into a data frame. Let's say one-hot data frame. We will say pd.data frame one-hot array, and columns are going to be equal to the column names. We will say one-hot encoder dot get feature names out and we will say country here. And we can check that one-hot data frame. We notice that we have new columns, one for each unique value in the country column, and these columns have binary values indicating the presence of that category. So if we had India here instead of Germany, this one also was going to be 1 and this one was going to be 0, and this is how one-hot encoder works. Okay, let's talk about our last technique. Sometimes the categorical variables have a clear ordinal relationship and you want to preserve that relationship in the encoded labels. That's where ordinal encoding comes in handy. We can also do this by libraries, but I'm going to do it manually here. We can say ordinal mapping and we are going to open a dictionary here. Let's say for the USA, let's give 1. Actually, I'm going to capitalize this. And let's say for the India, we will say 2. And for the United Kingdom, let's say 3. For the Germany, let's say 4. And for the Brazil, let's say 5 here. So we will use the map method here. Let's say df country ordinal, and we are going to say df country, and we will use that map method here, and we will say ordinal mapping, and let's see our data frame. So you can see that our country ordinal column has 1, 2, 3, 4, 5. Actually, I wrote these numbers because of that. So if we enter 2 for the USA, it was going to display 2 in here. So that's the logic of the ordinal encoder. With ordinal encoding, we manually assign numerical labels that capture the ordinal relationship in our data, if there is one. So let's quickly talk about these three advantages and disadvantages, and then we can finish the video. I'm going to start with the label encoding here. Also, I'm going to write this when I'm talking about the advantages of label encoding are it's easy to implement and it requires less computational overhead. And the disadvantages of it is can introduce ordinal relationship which may not be present that we talked about. And let's talk about one-hot encoding here. And for the one-hot encoding, the advantages are creates binary columns and removes ordinal assumptions. And the disadvantages are increases dimensionality of the dataset, which can be a problem for some algorithms. Like if you have 20 unique columns, you need to use at least 19 of them if you are using one-hot encoding. And at the ordinal encoder side, let's say ordinal encoding, the advantage is preserves ordinal relationships, and the disadvantages are not useful for nominal data. Manual mapping can be laborious. Thanks for watching the video. I'm sharing 2 or 3 new videos every week about data science and Python programming. You can subscribe to my channel for more videos like this. I shared a free data science bootcamp where I teach Python, Pandas, NumPy, Matplotlib, Plotly, Seaborn, and scikit-learn with 3 projects. The video is about 7 hours and it's completely free. You can just reach to that video from the cards of this video or the link in the description.